Good morning. Welcome to Mission Control Houston at NASA's Johnson Space Center. The folks you see here this morning are members of one of three teams of flight controllers that work in shifts around the clock to monitor operations of the International Space Station and work with the Expedition 57 crew members. Commander Alex Gerst and his crewmates have been busy getting ready for the arrival of three new crewmates, as well as a shipment of supplies that should be just a few days behind them.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. A building material that has been used throughout human history is being tested by astronauts aboard the International Space Station. This week, NASA's Serena Anand-Chancellor worked on an experiment using cement. The MVP Cell 5 experiment uses a centrifuge to impart 3 simulated gravity levels to different cement samples. The variations in gravity levels matches those of lunar gravity, Mars gravity, and microgravity. The process of making cement, hydrating a powder and letting it dry to harden, creates microstructures that result in elaborate combinations of phases, ultimately determining the material properties of the hardened cement. By solidifying cement in microgravity, researchers minimize gravity-driven phenomena and are able to create a different microstructure than that observed in typical laboratory conditions on Earth. Researchers aim to understand this process of microgravity. This knowledge is essential to advancing the use of cement in extraterrestrial settings, such as the Moon or Mars. This knowledge could also lead to improvements in manufacturing processes here on Earth as well. It will not be long until the number of residents aboard the space station doubles. Next week, NASA astronaut Anne McClain, Canadian Space Agency astronaut David Saint-Jacques, and cosmonaut Oleg Kononenko will launch inside a Soyuz from the Baikonur Cosmodrome in Kazakhstan. Make sure you tune in to NASA TV on Monday, December 3rd, starting at 6:30 a.m. Eastern for live coverage of their launch, docking, and welcoming aboard. Sunny Williams is a veteran station commander and experienced spacewalker, but there is still a lot of training to do before her next flight. Assigned to the second mission on Boeing's CST-100 Starliner, she recently did some spacewalk training in virtual reality to prepare for her next long-duration stay aboard the space station. To see the latest as we get closer to these first commercial crew flights from Boeing and SpaceX, visit nasa.gov/commercialcrew. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
NASA TV and NASA.gov will have full coverage of the upcoming dynamic activity, starting with the Soyuz operations on Monday morning. Live coverage from the Baikonur Cosmodrome begins at 4:30 a.m. Monday morning Central Time. That leads to the 5:31 a.m. launch of the 57 Soyuz spacecraft, with Commander Oleg Kononenko of Roscosmos and flight engineers Anne McClain of NASA and David Saint-Jacques of the Canadian Space Agency. We'll be back on the air at 10:45 a.m. Houston time with live coverage of Soyuz docking to the station. That's expected at 11:31 a.m. And then back again at 12:45 Central to see the new station crew members come on board. Soyuz hatch opening is targeted for 1:35, followed by greetings from station program officials and family members. NASA astronaut Anne McClain is making the first spaceflight of her career. The native of Spokane, Washington, is a colonel in the U.S. Army with a degree in astronautical engineering from West Point and a couple of master's degrees on top of that. But there's more to know about her than that. Things like her unusual birthday request in the 6th grade, her favorite sport, and the fate that befell her favorite movie at the hands of her brother.
Okay, one thing that most people don't know about me is that I've wanted to be an astronaut since I was 3 years old. That's when I first told my mom that I wanted to be an astronaut. When I went off to preschool, I told her I was going to school to learn to be an astronaut. And when I was in kindergarten, I wrote my first very poorly written book on going to space on the Soyuz vehicle. When I was in 6th grade, I had a birthday party and I asked every single one of my friends for a calculator for my birthday. And I didn't tell my parents because I was too embarrassed, but I got a lot of calculators and I was super nerdy about it. But one of the things that I learned was, you just got to be yourself. I wanted a bunch of calculators. I got a bunch of calculators, and that was okay. I was a huge nerd then, and I'm still a total nerd now, but hey, nerds get to go to space. Another thing most people don't know about me is that I played rugby. Well, maybe if you're close to me, you probably know that because I'm a little bit crazy about rugby. And the last time that I played was about a week before I got selected here at NASA. I played in the English Premiership in England, and then I went back and I played on the U.S. national team. One of the things that I learned about myself playing rugby that I apply every single day is when you think that you have given everything and you have nothing left to give physically and mentally, you have a reserve that you can dip into and you can just keep going. I was a helicopter pilot in the Army. I flew helicopters for about 10 years before I became a test pilot. And one of the things that I learned flying helicopters is that when something looks really risky from the outside, that people that are doing it on the inside, they're not professional risk takers, but they're probably professional risk mitigators. One summer, I watched the movie Top Gun so many times, probably 3 times a day for a matter of months, that my brother finally took the tape out of the VHS and broke it over his leg so I could never watch it again. I was absolutely devastated, and so maybe it's partly his fault that I have to go live that dream as a military pilot. But you never know where you're going to get inspiration from, and if you're inspired, well, then just keep doing it, even if your brother says not to.
McLean and her crewmates will be helping with some other vehicle traffic taking place around the International Space Station in just a few days. A SpaceX cargo ship is scheduled to launch from the Cape Canaveral Air Force Station on Tuesday, December 4th. NASA will provide live coverage on NASA TV and NASA.gov. That'll start at noon Central Time. Launch is coming up at 12:38 Tuesday. And rendezvous capture and berthing to the International Space Station not until Thursday morning, December 16th. The 16th Dragon cargo ship will deliver supplies and equipment for the Expedition 57 crew, along with a lot of scientific research materials, including a test of robotic technology for refueling spacecraft, a project to map the world's forest, and 2 student experiments that are inspired by Marvel's Guardians of the Galaxy series. The SpaceX Dragon cargo ship and the Northrop Grumman Cygnus cargo ship that's already attached to the International Space Station were developed as the result of a NASA program that was designed to help commercial industries get involved in spaceflight and space research. Alpha Space, the company responsible for the Missy flight facility, is another example of the results that program has produced.
Alpha Space was formed in 2015 and really is a product of this new commercialization in low Earth orbit. It was formed specifically to create a commercial payload that would be available in space for private industry. The Missy dates to the early 2000s, was the first mission. It's been utilized by NASA, by the Department of Defense for different experiments. And then around 2010, NASA put out a call for ideas to privatize portions of the space station. And so we responded with a proposal to that, and that's how we ended up with our cooperative agreement. For material scientists who want to test their materials or components in a harsh environment, the Missy platform really offers the most harsh environment that's available, and that's external to the space station. Previous Missies were one-time use, sort of suitcase style. They would open up and expose these materials to space. The MISSI platform is a permanent platform that's all robotically serviceable, commandable from the ground from our operations center here. We don't only test materials, we can also do technical demos, we can test circuitry, computer boards, cameras, and its serviceability and changeability allows science to continuously happen for 10 years going forward. Every day, new commercial companies are coming into the fold of this new economy that's developing. I think the space station is a great platform to start commercialization, and I think platforms like the MISSI are going to drive a new demand in space.
Now, part of the science mission of the International Space Station is to take advantage of the weightless environment in low Earth orbit to do research on new technologies that can benefit future exploration or life on Earth, and maybe both. For example, the station is now home to the Refabricator. That's a 3D printer that can make things and then recycle them and 3D print new things with the same plastic.
The In-Space Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's In-Space Manufacturing Manager at Marshall Spaceflight Center in Huntsville, Alabama, says, recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough. For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, we can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need and without having a large stockpile of extra materials. The Refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the Refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The Refabricator's technology demonstration will be composed of 2 phases. During each phase, the Refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the Refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a Refabricator, and then select your new phone case or a kitchen gadget or the raw filament that you can use in your 3D printer at home. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
The job of an astronaut on the International Space Station includes working as a laboratory assistant for scientists doing research in space and doing needed maintenance to keep their home on orbit operating safely and efficiently. But some of the crew members have also been making videos to help students learn about science, technology, engineering, and math topics. The STEMonstration videos. In this one, astronaut Joe Acaba talks about exercise on orbit.
Hey there, my name is Joe Acaba, and I'm living and working on the International Space Station as part of Expedition 53. One of the best parts about living on the space station is being able to float. Just like you walk from place to place throughout your day, we float from place to place throughout our day. However, we have learned that the same thing that allows us to float, microgravity, is hard on our bodies over time. Our muscles and bones are made of millions of tiny units called cells, and these cells can have problems in microgravity. Up here on the station, bones and muscles no longer have to support the weight of our bodies, so they get weaker. Astronauts could develop something called muscle atrophy, where our muscles become weak from lack of use. Each bone in your body is made of cells too. A healthy bone has more density than an unhealthy bone. Weakened bones can lead to a disease called osteoporosis. Fortunately, our scientists at NASA have figured out one way to keep astronauts healthy and strong. It's called exercise. Let's take a look at how astronauts exercise in space. This machine here is the Advanced Resistive Exercise Device, or we call it ARED. It simulates free weight exercises in normal gravity to work all the major muscle groups. ARED's primary goal is to maintain our muscle strength and mass so that we have less of a recovery period when we land back on Earth. All right, so there's looking at lifting. But what about a little cardio? We have a treadmill for that. Let's check it out. Staying physically active helps both astronauts in space and humans on the ground to stay healthy. And it prevents muscle atrophy and osteoporosis. Now you can try the activity connected to this video to learn more about muscle and bone cells. I'm Joe Acaba, and I hope you enjoyed learning about exercise on the International Space Station. We'll see you next time.
There's science about space and science to support future space exploration. And some of the science on the International Space Station is aimed closer to home, helping improve the lives of us Earthlings who never get to leave the planet. Here are a few examples.
The International Space Station is the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
The space station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
The weightless environment will give us insights into things like diabetes and maybe even cancer.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
If we wouldn't have conducted experiments on the ISS, we wouldn't have known that you could use cold atmospheric plasma in such broad application areas we're now exploring.
One of the most promising results has been gained by studying a protein associated with Duchenne muscular dystrophy.
We may be able to slow the disease by half, potentially doubling the lifespan of many of these DMD patients.
We provided iServe imagery for many natural disasters, including floods and fires, for deforestations, for volcanic eruptions, and for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
I think it's made people much more aware of the issues of water quality. That's a very powerful thing.
Having the HYCO on the International Space Station has been the ideal test bed for our research.
We can monitor these water bodies from space, and if we can reduce exposures both to humans and even animals, then we've achieved our goal.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The space station has done so many things for life on planet Earth. It shows us what human beings can do working together. It shows the science that we can discover.
Over 2,000 experiments have flown on board ISS. 170 countries around the world have participated in some fashion, either in the ISS itself or in one of the experiments. Our rate of research is actually increasing. We're doing more today on board the space station for research than we have ever done before, and that's only going to continue in the future.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
While NASA's International Space Station program works closely with its partner space agencies around the world, NASA's Commercial Crew program is working with Boeing and SpaceX to get 2 new ships ready to bring astronauts to the International Space Station. In August, NASA Administrator Jim Bridenstine came to the Johnson Space Center for a public announcement of the men and women who will be on board for the first test flights of those 2 commercial spacecraft, the people who will become the first astronauts launched to space from the USA since 2011.
Introducing NASA astronaut Bob Behnken.
I think if you ask any of us as graduates of a test pilot school program, what we wanted to do as the dream job, it would be the part of the development of a new spacecraft.
Introducing Boeing astronaut Chris Ferguson.
There's just something about going to space that has always been special. And I always thought I could satisfy my curiosity by going one time. And I quickly found out that that didn't work. Space is just, there's something magnetic about it.
Introducing NASA astronaut Doug Hurley.
You, as one of the astronauts flying the vehicle, how you interact with that vehicle, whether it's controlling it, whether it's monitoring it, whether it's living in it and getting it to the space station and back. I mean, that's really what we bring to the table.
Introducing NASA astronaut Eric Bowe.
We have simulators now. We have all these things that are mainly hardware, things you can really touch and feel, and you realize it's getting close. And so to me, that's what really makes this time really exciting, is because you can really imagine it now, because you got the hardware and you know it's going to go into space here shortly.
Introducing NASA astronaut Nicole Anapu-Mann.
I'm most looking forward to launching from American soil, and then when I do get to space, looking back and seeing Earth and seeing America and all the people that have worked so hard to make this possible, and I look forward to sharing that moment with everybody.
The Boeing and SpaceX crew vehicles being developed in the Commercial Crew program will keep the International Space Station fully staffed and operating, while NASA turns some of its attention to getting ready for the next step in human space exploration, going back to the moon and on to Mars. Today, to whet your appetite, here's a feature that will help us all see what those future missions of discovery will look like as America turns an inquiring eye out into the solar system.
from the Kennedy Space Center in Florida at T-minus 3 hours and holding.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
Patience, not only for our expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Crew ingress and work at this time.
Okay, then. Flight crew O2C, close among your visors and initiate O2 flow.
T-minus 10, 9, 8, 7, 6. All the engines up and burning. 2, 1, 0, and liftoff.
The dawn of Orion and a new era of American space exploration. If you'd like to get another look at any of the stories we showed you today, check us out on YouTube and on Facebook. There are the addresses in the handy blue box. And while you're at either of those places, check out all the other cool stuff you can find about NASA and America's human spaceflight program. Also, while you're out on the internet, check out Houston, we have a podcast. Folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays, and today, Gary Jordan continues the remembrance of the beginning of the International Space Station operations in orbit 20 years ago, talking with former astronaut Jerry Ross about the space shuttle mission that began the station's assembly in space. Go to nasa.gov/podcasts, where you can find today's episode and all of the Houston We Have a Podcast episodes. You will also find in the same spot the full library of all the NASA podcasts. And you can listen to any of them by going to Apple Podcasts, Google Podcasts, or SoundCloud. This is Mission Control, Houston.